Nuclear chemistry, day 5. Here we go. How do we determine half-lives? So the first question is a do not question. Pause the video and do the do not question. Okay, we're back. So we learned, guys, when we have 2 on the left, 2 on the right, that is artificial transmutation. We learned 1 on the left, 2 on the right was natural. Those are particles that give off radiation naturally. So 9 plus 4 is 13. 1 plus what is 13? Well, 1 plus 12. 4 plus 2 is 6. 0 plus what is 6? Well, 6. So what tells us the element symbol? The mass of the number? Well, it's always the atomic number. You go to your periodic table, atomic number 6 is carbon. Okay. Let's move on. So the first problem at hand over here is just half-lives. Now, guys, you learn half-lives in earth science. So it says here, the amount of time it takes for the nucleus of a radioisotope to decay half its mass. Now, a little clip I gave you over here, this little hint says over here, if 2 units of time are present, divide the units of time based on the formula below. Unfortunately, guys, they removed the formula here like 5 years ago. I don't know why, but they did. It's total time over the half-life, okay? And you see how we're talking about here in this chart. You notice how the half-life starts at 1, and then after 1 half-life, half the mass is gone. So you have half. What's half of a half? Well, a fourth. Well, what's half of a fourth? An eighth, so on and so forth. Okay. So, sorry about that. The computer seems to be doing that again. Okay, here we go. Let's go over the first half-life problem here, guys. All right. If the half-life of isotope is K42 is 12.36 hours, that means every 12.36 hours, half the mass is gone, right? If you have 100 grams, how much would be left after 37.8 hours? So now, we agree we have 2 units of time here, correct? So we have 2 units of time. The larger number goes in top, because that's the total time, over the half-life, which goes in denominator. You simply divide the 2 numbers, and that's going to give you the number of half-lives. Then that tells you how many lines you draw. Because there's 3 half-lives, we're going to draw 1, 2, 3 lines. So now, it says here if you had 100 grams. So the mass here starts at 100 grams, right? That's what we started at. So we're simply going to divide it by 2 3 times. What's half of 100? Well, 50. What's half of 50? 25. Half of 25. 12.5 will remain because each line represents 1 half-life, we said before. All right. So let's go over several practice questions here, okay? All right, let's do the next one over here. So, by the way, I put table N on the side here so you can see it, all right? So you don't have to keep going back and forth. Question says here, how many grams of a 32-gram sample of P32 will remain after 71.44 days? Okay, so they're giving us the mass, they're giving us the time here, 1 unit of time. Well, they're not giving us the half-life, guys, of P32. So we can look it up on table N. Well, let's scour table N and look for it. There it is. That is P32. And look, this over here is a half-life. Oh, sorry. This over here is a half-life, right? So here's your half-life column. So let's go back to P32. The half-life says here 14.28 days. So what's the total time they gave us here? Well, 71.44, because the larger number always goes on top. All right, you can't get a fraction of a half-life. Makes no sense. Over the 14.28 days. So take out your little calculator and divide. I'll pause it right now. Divide, please. Okay, and that's going to give us 5 half-lives. So how many lines do we draw? Well, we're going to draw 5 lines. 1, 2, 3, 4, 5. What's the mass we're starting at, guys? Well, it says over here, 32 grams. So, what's half of 32? Well, take out your calculator. Press take 32, divide by 2. Well, it's 16. What's half of 16? 8. What's half of 8? 4. What's half of 4? Or 4 divided by 2? 2. What's half of 2? 1 gram is your final answer, guys. And by the way, you always go below the bottom line. So the answer is 1 gram remains. All right, let's look at the next question. What is the mass of Ra-226 remaining in the 16-gram sample Ra-226 after 6,396 years? So they're giving us the mass again, they're giving us the time. What are they not giving us? Well, they're not giving us the half-life of this element of Ra-226. So let's scour the table and look for Ra-226 here. Here it is. There it is right there. And the half-life to tell you is 1,599 years. Right there it is. That means every 1,599 years, half the mass is gone, guys. All right? So here we go. It says they give us the total time here, 6,396 years. What's the half-life here? The half-life is this number, 1,599 years. Okay? You divide them, you're going to get 4 half-lives. So then how many lines we draw? Well, 4. 1, 2, 3, 4. What's the mass they started us, guys? 16. What's half of 16? 8. Half of 8? 4. Half of 4 is 2. Half of 2 is 1. Well, okay, right here. 1 gram remains there, guys. 1 gram. Okay, let's move on. So, if the half-life is CS137, so now, guys, look, they give us the half-life now. So actually, we don't need to go to table N, right? 30.2 years. If you had 200 grams, how much would you have left at 120.8 years? Now, you agree. We said before, when you have 2 units of time, you simply divide, right? We've been doing the whole time. The larger number goes on top. So 120.8 over 30.2 equals, well, divide, you get 4 half-lives. By the way, I've seen exams where they had 6 or 7 half-lives. So you have to draw 6 or 7 lines, right? So 1, 2, 3, 4. What's the mass they start us, guys? 200. See how you calculate. What's half of 200? 100. What's half of 100? 50. Half of 50 is 25. Half of 25 is 12.5 grams. Okay. Let's move on. How many grams of a 32-gram sample? 32-gram sample of K37. We had 6.15 seconds. So you notice, guys, it gave us 1 unit of mass, 32 grams, 1 unit times 6.15. That means we need to look up the half-life for K37. So scour our table over here. There it is, K37. So they gave us the total time here, 6.15, right? Divided by the half-life, which is, says right there, 1.23 seconds. Okay, so you divide them, and you're going to get 5 half-lives. Now, how many lines do we draw? Well, since there's 5 half-lives, draw 5 lines. 1, 2, 3, 4, 5. So what's the mass we start out here? Well, 32. Half of 32, 16, 8, 4, 2, 1 gram. Now, it seems like 1 gram is the answer all the time, but it's not, okay? It just so happens to work that way. All right? 1 gram is the answer there. All right. Let's move on. Last 2 questions here. Okay. A radioactive sample is a half-life. Now, they gave us a half-life, guys. Oh, sorry, wrong one. They gave us a half-life here, so you don't have to go to table N, right? So it's has a half-life of 2.5 days. How much of a 20-gram sample remained after 10 days? So we have 2 units of time, correct? We have to look up the second unit time on table N. So the larger number goes on top over the smaller number, 2.5 days. And again, how many half-lives? Well, what's 10 divided by 2.5? Quickly on the calculator. 4 half-lives. Very good. So how many lines do we draw? 4. 1, 2, 3, 4. We're going to start with how many grams to start with here? 20 grams. What's half of 20? 10. Half of 10, 5. 2.5. 1.25 grams is our final answer there. Okay. What is the mass of a 16-gram sample of I-131 after 24.06 days here, guys? All right, let's see. Well, they gave us 1 unit of mass and 1 unit of time. So that means we need to look up the half-life, correct? Good. The half-life of what? I-131. Well, let's find it. I-131. There it is. And the half-life they gave us here was 8.021 days. So, what's the total time they gave us here, guys? So, 24.06 divided by the half-life, 8.021 days. You divide them, you're going to get, well, 24 divided by 3 is, 24 divided by 8 is 3 half-lives. Okay. So now how many lines you draw? That's right, 3 lines. 1, 2, 3. What's the mass we start at, guys? Well, it's 60. What's half of 60? 30. Half of 30? 15. Half of 15 on your calculator is 7.5 grams is my final answer. That remains. All right, guys, that's it.